Good morning, students. We'll start the new course, that is blockchain and its application, and the code is TCS-433. And this course is only for BTech CST 4th semester students. First of all, I am Dr. Mohammad Wahid and I am Associate Professor in the Department of Computer Science and Engineering at Graphicera Deemed to be University, Dehradun. This is about my qualification. I did my BE in CSE from KC Dwarhat, MTech in Computer Network Engineering from Graphicera, and PhD in Computer Science and Engineering with specialization in Network Security from C-Star, IIIT Hyderabad, and postdoc in Network Security from the Lab of Cybersecurity and Networks Lab, Innopolis University, Innopolis, Russia. This is about my research background. So far, I published 84 papers in the reputed journals and conferences in the domain of information security, authentication, IoT, cloud computing, big data, and blockchain. So if any of the student is interested doing research in these domains, they can communicate with me. This is another thing. I published my papers in some of the reputed venues, and some of them are topmost venues of the domain like IEEE transaction in dependable and secure computing, IEEE transactions on smart grid, IEEE Internet of Things journal, industrial informatics, and many more. Some of the awards that I won so far, that is University Gold Medal in my MTech program, Young Scientist Award by the Department of Science and Technology, Dr. APJ Abdul Kalam Award, that is for my innovative works, and ICT Express, which is a Elsevier journal, and that is Best Research Reviewer Award in 2019. So what are the outcomes of this particular course, blockchain and its applications? So after the completion of this course, a student will be able to explain symmetric and asymmetric key crypto systems. As you know, blockchain is about your encryption, decryption, and digital signatures. So that's why it is mandatory to discuss about these topics in the beginning. So a student will be able to explain symmetric and asymmetric key crypto systems, know the use of cryptographic techniques in blockchain technology, analyze the different types of blockchain mechanisms, use blockchain technology to implement security protocols, apply blockchain technology in different applications, develop blockchain based security protocols. So these are the outcomes of this particular course. Now, what is the grading scheme of the course? That is as per the university scheme. And what is the criteria? Criteria will be different for internal marks as well as for the external marks. So internal marks will be evaluated on the basis of your performance in the class, like your queries and answers, performance in the class test, quiz and assignments, your attendance, especially if it is offline. So we will see what will happen in the next few months, and behavior with the teachers and classmates. And criteria for external marks is performance in the written exam. Then what are the textbooks that you have to follow for this particular course? So these are the two textbooks which are very important, so you have to remember, or you can purchase them. And some of the books are also available in the library, that is cryptography and network security principles and practice. So it's a textbook by William Stalling. And another textbook that is for the blockchain part, that is basis of bitcoins and blockchains, and introduction to cryptocurrencies and technology that proves them, and it's a textbook by Anthony Lewis. So you have to follow these two textbooks. So now let us start the unit number 1 of this course. First of all, I will give you the brief overview of cryptography. So basically, what is cryptography? The word came from the Greek language, that is cryptos. Cryptos means hidden, secret, hidden or secret, and graphein. Graphein means to write something. So if we merge these two terms, then we will have secret writing. So what is the meaning of cryptography? That is secret writing. So if somebody asks you what exactly is cryptography? So cryptography is a mechanism of protecting information and through the use of certain codes so that intended recipient can read and process it. The generated codes allow information to be kept secret. So that is, you can say, the advantage of the use of cryptographic technique. The generated codes allow information to be kept secret because we have uh, created a ciphertext from our original message. So that's why the message can be kept secret, and it converts data into a format that is unreadable for an unauthorized user. So what is unreadable format? That ciphertext that we have generated after the application of cryptographic algorithm. So that's why that become unreadable for any third party or for the attackers, allowing it to be transmitted without unauthorized entities decoding it back. So that is a problem for the attackers. They can't decode, or you can say they can't decrypt it, because for the decryption part they need the corresponding key. So it is a method of storing and transmitting data in a particular form so that only those for whom it is intended can read and process it. So that is very important thing that you have to remember. For whom it is intended can read and process it. So how they can read or and process? So they can read it after the decryption procedure, and for the decryption procedure they need a key which is called as a key for the decryption procedure. So that's why we need a key. So cryptography not only protects data from theft or alteration, but it also be used for the user authentication. That I will tell you in the future lectures how we can use cryptography for the user authentication. Then another related term is there, that is information security, which is very broader domain. In information security we need different types of mechanism, and cryptography is a one mechanism that we use in the information security to secure the information. So information security is the set of processes that maintain the confidentiality, means secrecy, integrity, and availability of the business data in its various form. Business data, you can say anything. For example, we have some information here in this university, for example student related records, some finance related records, faculty related records. So that is our, you can assume it like a business data, and it is designed to protect the confidentiality, integrity, and availability of data from malicious intention. So what is the malicious intentions? Malicious intentions, you can say there is some attacker in the channel and they want to leak this message. They want to change this message. So that is, you can say, the malicious intentions. So we have confidentiality, integrity, and availability, which are closely related to our data, our information. So confidentiality, integrity, and availability are sometimes referred to as the CIA triad of information security. That is CIA triad of information security. So if somebody asks you in the interview, what is CIA triad? So CIA triad is C for confidentiality, I for integrity, A for availability. And these properties are closely related to your information. Later on we will talk about CIA in detail. So it is basically information security, basically the practice of preventing unauthorized access, use, disclosure, disruption, modification, inspection, recording, or destruction of information. So there are very important terminologies that you have to remember. Prevention against unauthorized access. Unauthorized access means there is some attacker and they want to access your data. So that is a unauthorized access. And if they are accessing your data, they may use it for their own interest. So that is use. Disclosure. So suppose they have access your data in the unauthorized way and somehow they have also disclosed your secret data. So that is disclosure. Disruption. Disruption means they want to disrupt the information that is there in that particular exchange of messages. Modification. They are trying to modify the messages. inspection. So they are inspecting the exchange information. What exactly the communicating parties are exchanging. Recording. Recording means they are recording your exchange messages. On some location or in some particular device, they are recording your messages. Destruction of information means they are deleting some part of the information or the entire information, that is destruction of information. So now you have to remember these basic terms. So information security is basically the practice of preventing unauthorized access, use, disclosure, disruption, modification, inspection, recording or destruction of information. And information can be anything like your details, means for example students details, or we can say your profile on the social media, for example your account on some social media network like Facebook, Instagram, your data in your mobile phone. Suppose you have stored some secret messages, some secret information in your mobile phone, and your biometrics information like information related to your fingerprints, your retinas and all, that is something related to biometrics. So some of the examples are given here. For example, during the First World War, multi-tier classification system was developed keeping in mind sensitivity of the information. So with the beginning of Second World War, former alignment of classification system was done. So basically they have started something related to information security in during the period of World War One. So there was a famous scientist, that is Alan Turing, was the one who successfully decrypted Enigma machine, which was used by Germans to encrypt the warfare data. So Alan Turing was the scientist, was English scientist from the England, and he has decrypted some of the messages which was encrypted by Enigma machine. So Enigma machine was used by the Germans. So during the World War One, Germans were using this machine for the secrecy of the exchange messages. So Alan Turing was the first scientist who has decrypted the messages of this Enigma machine. So it is a typical picture of that machine, Enigma machine. So if you provide some message here, so basically this will decrypt your messages. So that is Enigma machine. So what are the general security requirements? So earlier we have also talked about these terms: confidentiality, integrity and availability. So again we will discuss about these terms in full details. So first thing is confidentiality, or in other words you can say secrecy. So this property provides protection of information against any kind of unauthorized access. So in another way, it is also known as privacy, which, or you can say secrecy, which protects the exchange messages against any kind of disclosure attack. So here our focus is protection of you can say secrecy, or we are maintaining the secrecy of the exchange information. So that comes under confidentiality. Then we have integrity. So it provides assurance of real and accurate data, means the information sender has sent, that should be received by the receiver. There should not be any change in that information in the channel. So it provides assurance of real and accurate data. The content of the received message should not contain any illegal insertion, unapproved modification and deletion. So data should be safeguarded against unauthorized modification. So that is your integrity. Then we have authentication. So it is used to validate the identities of communicating devices and users. So basically what is authentication? It's a process of verifying the genuineness of somebody. For example, it can be a user, it can be a device. So mutual verification of identities is mandatory to start a secure communication, and it should be conducted in advance. So suppose there are some parties and they want to exchange their information in the secure way. So for the secure exchange, they have to establish a secure session key in the advance, in the prior basis. So for the establishment of that secure session key, they have to mutually authenticate between each other. So that's a condition there. So authentication, basically it is used to validate the identities of communicating devices and users. So for example, in an IoT environment, we have authentication, and authentication may be happen among the smart IoT devices, various kind of servers like fog server, cloud server, edge server, different types of users, and the service providers. So it's a typical example of authentication. Then non-repudiation. So it provides assurance that any entity should not deny the validity of something, for example, a message. It is one of the important services in information security, which provides proofreading the origin of message and integrity of the data in that message. So therefore it is very difficult for the illegal entities to deny the origin of the message and authenticity of the message. So we have like digital signatures kind of mechanism in non-repudiation. So digital signature methods are useful for the non-repudiation. For example, in case of an online transaction, where it is important to assure that the party to whom the contact was made or the communicating party should not deny the originality of his or her signature on that particular report. So we have two types of non-repudiation. First is source non-repudiation. Second is destination non-repudiation. So what is source non-repudiation? It provides assurance of genuineness of the sender. So source non-repudiation means something related to the sender. So it provides assurance of genuineness of the sender. And what about destination non-repudiation? It provides assurance of genuineness of the receiver. So that is the difference between source and destination non-repudiation. Then we have another mechanism, that is authorization. So authorization procedure is used to regulate device or user privileges like access restrictions for a network or for a system resource. System resource can be like your file, data applications and services. So generally it is anticipated by authentication procedure for the verification of identities of device or user. So basically what is the use of authorization here? So suppose you have a number of resources in your system, or your system is hosting a number of resources. So who can access which resource? Can they authorize to access that particular resource? So how to restrict these users so that they access a resource as per their you can say a role. So that is for that particular purpose we need a mechanism, and that is called as authorization mechanism. So generally it is anticipated by authentication procedure, and then we also need a authorization. You can say, for example, you will assign some tokens to them so that they can access that particular resource. So that is authorization. So in general authority, for example, administrator designs and implement the access roles for all available resources, means who can access which particular resource. So that is uh, authorization. Then we have forward secrecy. So if an entity, for example, a smart home user or a smart IoT device, leaves the communication network, then it must not have any ability to access the future messages. So that is very important. If somebody asks you what is forward secrecy, so basically if an entity, and that particular entity has left your network, then it must not have any ability to access the future messages. That means these users or these devices, they will not be able to access your future messages. So that comes under forward secrecy. Then we have backward secrecy. So if an entity is just deployed in the communication network, then it must not have any ability to access the previously exchanged messages. Means just now this device has joined your network. So that particular device or that particular user should not be able to access the previously exchanged messages. So that is backward secrecy. Then what are the different applications of cryptography? So like we have uh, its use in secure communication. So one that all of us use frequently, that is encryption. So encrypting communication between us and another system. So the communication which is happening among the communicating parties, we can encrypt or we can make it secure by the help of encryption decryption procedure. So that is secure communication. To achieve this secure communication we need cryptography. So this is most commonly used for communicating between a client program and a server program. So examples are a web browser and a web server, or an email client and email server. So to make the internet more secure, most communication protocols have adopted encryption. So for example, we have secure socket layer SSL. So in that SSL, we use different cryptographic algorithm for the encryption decryption procedure. So many older protocols have been dropped in favor of new encrypted replacement. The best example is web encryption, since here you can choose between a clear or encrypted version of website by switching between HTTP and HTTPS in the URL. So as you know, we have already discussed this in the last semester in your cybersecurity course. So HTTPS is the secured version of HTTP. So suppose you have to access something or some resource over the web in a secure way, then you can use HTTPS. So that is a secured version of HTTP. Basically it's a HTTP in combination with the secure socket layer SSL. So most large companies now use the encrypted form by default, and you shall see that any visit to Google, Facebook or Microsoft or this Office 365 that we use for accessing some Microsoft related websites, email accounts, so they use HTTPS to achieve the secure communication. Then we have another interesting thing that we have in most of the application that we use these days for the chatting. For example, our chatting applications like WhatsApp, that is end-to-end encryption. So email is one area where encryption is not widely in use. When email moves from server to server and from server to you, it is encrypted on the mail server and on your system. However, an administrator can read it. So there are options to implement end-to-end encryption for your email, and that mechanism is called as pretty good privacy (PGP). So truly secure messaging system where only the sender and receiver can read the message are those where encryption has been built in from and start. For example, we have WhatsApp and they use end-to-end encryption. Means anybody in the channel, any device, they can't decrypt your message. Only that receiving party has the ability to decrypt your message. So that's why it is end-to-end encryption. So it's a typical scenario of end-to-end encryption. So what we have two communicating parties. One is Bob, another one is Alice, and they are exchanging something, some information they are exchanging. So here in the Bob's device we have, for example, some message that is send me S. So Bob's uses Alice public key to encrypt. So then Bob's device will encrypt this message, and this is our encrypted message, something like 6EK, and then this encrypted message will be exchanged, will be sent to the channel. So here what we have encrypted emails to the Alice. So that encrypted message we have here in the channel, and this is some, you can say, some server form or some intermediate devices. So we have here Alice public key and Bob's public key. So since public key is known to everybody who are there in the channel, so that's why that can be stored. So now what will happen at the Alice end, Alice's device will receive this encrypted message, and then this will be decrypted. So Alice uses her private key to decrypt the message, and then that Alice will get the original message, that is send me S. So here you can see what you have understood from this particular scenario. So these are the, you can say, intermediate nodes, and on all these intermediate nodes what we have only these encrypted message, not the original message. So anybody in the channel, they don't have ability to decrypt this particular message. So that's why it is end-to-end encryption. So only Alice has ability to decrypt this particular message. So that is your end-to-end encryption procedure. Then third thing is storing data securely. So we all store a large amount of data, and any data is valuable to at least the person who generated it. So every operating system uses encryption in some of the core components to keep passwords secret, conceal some parts of the system, and make sure that updates and patches are rarely from the maker of the system. So a more notable use of encryption is to encrypt the entire drive and require correct credentials to access it. So basically, why we are encrypting the entire drive? Basically, we are storing our data securely. Then fourth is storing the passwords. So one of the main uses of this is to store the passwords in the secure way. So it is very risky to store passwords in an accessible way. So if you store them in the plain text, anyone who has access to the system, it may be a legitimate or some malicious user, can read that particular password, which is not a good thing from the security point of view. So therefore we need some encryption mechanism. So encryption is the only a partial answer to storing the passwords. So that is for the application. So we can store the passwords securely by the help of cryptography. So if someone has access to the system storing the encrypted password, they will be probably have access to the encryption key to decrypt the password. So hashing on the other hand produces a relatively useless value for the attacker. So there is another approach, that is hashing. So what we will do, basically we will create a hash value from the original password, and then we will store this in the memory or database, and on each attempt of that particular user we will basically match the hash value. So that is hashing. Hashing on the other hand produces a relatively useless value for the attacker. A system will take the password on login and hash it and compare the hash value. So that is another security mechanism. We can use hashing. So at no point will the system or the attacker have access to the plain text password. So it's a typical scenario which is provided here on this particular slide. So what we have a username and password. So they are providing that value Henry and some password value. So then hashing algorithm basically create a hash value from this particular password. So that is HD23, something like this, and then that particular hash value will be stored here in the database, company's user database. So hash key produced and checked against stored password hash key if the same they are letting. So suppose this hash value of the password matches in an attempt, then that particular user will be allowed to access this system or will be able to log in into this particular system. So that's how we can provide security to the passwords. And another interesting application which is very famous, that is chip based payment cards. Basically that the transaction that we do using our debit or credit card. So there we use cryptography. So a chip card is the standard size like plastic debit or credit card which contains an embedded microchip as well as a traditional magnetic stripe. So this chip contains encrypted information to increase data security when making transactions at stores, terminals and ATMs. So chip cards are also known as smart cards, chip and pin cards, chip and signature cards. For example, we have Europay, MasterCard and Visa. So the chip card is the global standard for chip-based debit and credit transactions. So here basically we use cryptographic techniques for the uh, uh, secure transactions. Then we have sixth application, that is digital currency. So digital currency is a form of currency that is available only in digital or electronic form, not in the physical form. For example, I have like 50 rupee note or 100 rupee note. So that is not like this. It's some digital value, that is digital currency. So it is also called as digital money or electronic currency or cyber cash, you can say. So digital currencies are currencies that only accessible with computer or mobile phones, as they only exist in electronic form. So since digital currencies requires no intermediary, they are often the cheapest method to trade the currencies. So all cryptocurrencies are digital currencies. So that's an example of digital currency. So digital currencies are stable and are traded with the markets. Whereas cryptocurrencies are traded via consumer sentiments and psychological triggers. So digital currencies are intangible and can only be owned and transacted in by using computers or electronic wallets. So that's a typical restriction with the use of digital currencies. We need some computers, we need some like internet related things, some computing devices we need, and we also need some electronic wallets connected to the internet. So in contrast, physical currencies like banknotes and coins are tangible. Transactions are possible only by their holders who have their physical ownership. So it's a typical scenario of digital currency. So what we have here in this figure, that is streamlining of digital currency payment. So what is happening here? For example, we have a party A and party A wants to send money to party B. So what will happen here? Party A will initiate this particular transaction. The transaction is represented online as a block. So that is some block value we have here in the. So what will happen here? Basically, from these currency value, some block will be created, and that will be put inside that block. Then what will happen in the third step? The block is broadcasted to the other parties of the network, like party A, party B, party C, party D, party E, and they are maintaining a, you can say, a shared ledger, that is also called as distributed ledger, a kind of a, you can say, distributed database, distributed shared database, you can say. So so that is broadcasted to this particular network. So what will happen in the first step? Those in the network approve the transaction is valid. So for example, party A has $10 in its account, and party A wants to send $5. So since $5 is less than $10, that means party A can do this transaction. So those in the network approve the transaction is valid. So party B, party C, party D, party E, they will approve this transaction, that this is okay. You can go for this transaction. So that is called as commitment process. So those in the network approve the transaction is valid. Then what will happen in the fifth step? The block then can be added to the chain, which provides an indeclinable and transparent record of transaction. So that will be available to everybody. Now what will happen in the step 6? The money moves from A to B. So since they are maintaining a distributed ledger, so then when that particular block is successfully added to the blockchain, then that can be transferred to the account of the party B. So that's a typical way of transaction in this digital currency network, or you can say in some blockchain based cryptocurrency network. So now we will talk about another topic, that is digital communication, which is very much related to the things that we have discussed so far. So what we have in the digital communication, we have like plain text, which is our original message, and ciphertext, which is a encrypted message. So by using some cryptographic algorithm, we have converted that plain text into some ciphertext message. So what we have here, we have two parties, one is Bob and Alice, and they are legitimate parties. And we also have an attacker here, that is Eve. So Bob wants to communicate with Alice in a secure way. So how they can communicate in a secure way? Basically, they will use a cryptographic algorithm so that they can encrypt and decrypt their exchange messages. And K1 is that particular key which Bob and Alice they are using for the encryption of their messages. So Bob and Alice, they will, first of all, they have to share this key through some secure channel, and after that they can transmit or receive the encrypted decrypted messages. So that is, you can say, a secure communication, a secure digital communication, you can say. So now this Eve is not able to access these messages because that is in the encrypted form. If Eve access, then Eve will not have any ability to decrypt that message. So therefore there is no use of such kind of uh, capturing of that type, that message. So that is secure communication. So I am again elaborating the previous slide. So what we have unencrypted source. Then we have done some encryption, that is encryption using a key. And we have encrypted result. For example, some encrypted message, and that we are sending to the receiver here at the receiving ends. So receiver will receive the encrypted file, then perform decryption over that file, over that encrypted received file, and then that receiver will get the original information, that is unencrypted file. So whatever they are doing here, either this encryption or decryption, they need this particular key. So that is the key, the use of this particular key, that is safely communicate, that should be safely communicated between the sender and the receiver. And since they are using a single key for the encryption as well as for the decryption, so that's why it is called as symmetric key cryptography. So they are doing this in the symmetric way. So that is, a symmetrical algorithm uses identical keys. Then what are the different components of a crypto system? So we can have around 5 components. First of all, the plain text. Plain text means your original message that a sender wants to send to the receiver. Then we have encryption algorithm. So it is a mathematical process that produces a ciphertext for a given plain text by the help of the encryption key. And we can represent this like this. So that is E means encryption, K means key, and that we are performing over a plain text P, and then we will get a C, which is a ciphertext. So that is encryption algorithm. So we need a encryption algorithm for the encryption operation. Then we have ciphertext. So it is the scrambled version of the plain text produced by the encryption algorithm using a specific encryption key. The ciphertext is not guarded, means ciphertext will go like this in the channel because it is already cipher, it is already transformed, it is already in the ciphertext form. So it is transmitted through a public channel, and it can be intercepted or compromised by anyone who has access to the communication channel. Means attacker can access your ciphertext, but there is no use of that capturing, there is no use of that kind of access because they don't have any information for the key, because they don't know the key. So that's why they can't decrypt this ciphertext. So there is no use of that kind of capturing. Then we have fourth component, that is decryption algorithm. So it is a mathematical process that produces a unique plain text for any given ciphertext and decryption key. So it is a cryptographic algorithm that takes a ciphertext and decryption key as input and outputs a plain text. So basically what is happening here, basically this algorithm will take your ciphertext and the corresponding key, and then this will produce a original message. And mathematically we can represent this process as like this, that is D for decryption procedure, K for key that they are using for the decryption, and C for the received ciphertext, and equals to P. P is the plaintext message that they are getting, that the receiver is getting. Then we have encryption key and decryption key. Encryption key that we use for the encryption procedure. Basically we do it at the sender's end. And we also have a decryption key that is used by the receiver for the decryption of messages. And if it is a symmetric key crypto system, then both these keys will be same. In case of asymmetric key crypto system or public key crypto system, both these keys will be different. So that is encryption key and decryption key. So for a given crypto system, a collection of all possible decryption keys is called as a key space. Basically we have a key space, and in that key space we have different keys values. So an interceptor, for example, attacker, is an unauthorized entity who attempts to determine the plain text. Basically, what is the objective of the attackers here? Basically, they want to know the what the parties are exchanging. Basically, they want to decrypt your encrypted message, and they also want to know about the key value. So attacker can see the ciphertext and may know the decryption algorithm. He, however, must never know the decryption key, because if they get the value of the decryption key, then they can decrypt your message. So this is the references. Basically, I put these slides. Some of the content I took from this book, that is Cryptography and Network Security, which is a standard book, and you have to follow this for this particular course, especially for your Unit 1 and Unit 2. Thank you very much. Your doubts you can discuss with me during the online doubt clearing session.